Hello, students. Mr. Murphy, of course, and we are talking lesson 9, decimal expansion of fractions, part 1. So we're going to identify the size and error when we truncate an infinite decimal to a finite number of decimal places. Truncate just means when we cut something off, right? Because an infinite decimal goes forever, and we can't add those because our calculators don't go forever and our paper doesn't go forever. So eventually we have to stop putting numbers to add, subtract, multiply, or divide. So let's try two repeating decimals. So we have 5/6 and 7/9. So if I convert them to decimals, I have 0.833333 plus 0.777. So I can just add those together. Okay. 3 plus 7 is 10, carry the 1. 3 plus 7 is 10, plus 1 is 11, carry the 1, etc. 8 plus 7 is 15, plus 1 is 16, so we have 1.61110. So that is a terminating decimal, right? It ends at 0 because we truncated our decimals, we ended our decimals, right? So what happens if we add the fractions, right? 5/6 plus 7/9 equals 15 plus 14/18, right? We multiply this by 3/3 and this by 2/2. We'll have 15 plus 14/18, which is 29/18. And the decimal for 29/18 is 1.6111. And that repeats forever and ever. So when I cut off my decimals, I had a terminating decimal that ended in 0. When I don't cut off my decimals and I just add my fractions, I get a slightly different number of 1.61 repeating. So why do you think we get different numbers as fractions than we do when we have decimals? Right? It makes a little sense if you think about it, because if I'm going to cut off the decimal somewhere, then I have a different number. That's all I have. So I'm going to get different answers. Does it do the same thing when I multiply? Sure. If I do 0.83333 times 0.7777, I get 648,05741. And if I add more 3s or more 7s, I'll get different numbers. If I multiply the fractions, 5 times 7 is 35, and 6 times 9 is 54, and 35 divided by 54 is 0.6, and 481 is repeating. So here I have 480. If I rounded, this would be 481. So it's really close, but still not the same number, because these two multiplying gives me this terminating decimal here. These two multiplying gives me a repeating decimal. So when we're converting fractions into decimals, we get a different answer. But what is the difference between 648,05741 and 0.6481 repeating? Well, the difference, if I subtract them, is 0.000173. And so that's just basically 1 in 10,000, right? The difference is 1 out of 10,000s, or 1/10,000, or 1/10⁴, or 0.0001. So in most instances, that's not a big deal, right? If I were building a house and my error on my measurement was 1 in 10,000 inches, that's not a big deal. You know, over long distances and stuff, it can make less and less of a deal. So a lot of times, truncating or shortening the decimals and multiplying is fine, but it's really better just to use the fractions, right? However, what about irrational numbers, right? So if these Repeating decimals, I just put them into fractions and then add, subtract, multiply, or divide. But what if I have two irrational numbers? And they can't be fractions, right? An irrational number is a decimal that goes on forever and doesn't repeat and doesn't end, and it can't be made into a fraction. So if I'm going to add, subtract, multiply, or divide two irrational numbers, I can't really do it, right? So if I have an irrational number, I'll just cut it off to whatever decimal I need it to be, and then add, subtract, multiply, or divide, right? And if I have repeating decimals, I can either multiply, add, subtract, multiply, or divide the fractions, or I can cut it off to whatever error is okay for me. So if 1 in 1,000 is fine, then I can cut it off like that in these decimals. So that's the lesson for today. So going from fractions, converting fractions to decimals does introduce a little bit of error, especially with repeating fractions or irrational numbers. The error isn't big, we just have to know what it is. All right, and that's all I have for you.